Hello everyone, so today I'm gonna continue doing some papers. This time around I'm gonna do Pyramid 3, and it's the most recent paper as far as I have. And the reason I didn't upload that frequently is because I have exams in school and stuff or whatever. So question 1, it's a trigonometry question. It's a standard one. So for part A, it's the intermediate value theorem, so you have to find, so since it's asking to find to show that there's a root between 0.7 and 0.8, we should do this. We should find G07, 0.7. Okay, actually I'm not gonna even calculate it. I'm just gonna look at the mark scheme. You should get around this value, and then G 0.8 should be 0.39. You just put in this number in all the excess, and then also remember it's radians, okay? And then since look at these answers, one is negative, one is a positive number, so what you write is change of sign, and gx is continuous function. So there's a root in this interval. That's all you have to write. And in part B, we have to show that the equation gx equals 0 can be written as this. So gx equals 0, that means 3x minus 5 plus 5 sine x squared equals 0. So that means 5 sine x squared, oh, the square should be inside by the way, would equal to 5 minus 3x if we move these to the right. And then we can divide by 5, would equal to 3/5x, okay? Then, remember, we can take the arcsine of both sides. Then we will have arcsine of x squared equals arcsine 1 minus 3/5x. If you don't know what arcsine is, it's the inverse function of sine. And then since arcsine sine means nothing, so it just cancels out, and we will have this result. Then this square basically means square root, or in the question's words, 1/2 power. There we go. Here's the iteration formula with the value P found in part B and starting with this 0.7. Okay, so x2 would equal to arcsine, this is part C, arcsine 1 minus 3/5 x1, and we have x1, right? x1 is 0.7, so this, and then take the 1/2 power of it. We will have around 0.7866, okay? And then part 2, by repeated iteration, find the value of a, okay? So that would be sine, you might not find arcsine in your calculator, but remember, arcsine just means sine -1 power. It's the same thing, okay? 1 minus 0.6 times 0.7, and then to the 0.5 power. Scheiße. That is minus degree, so that should be radian, 0.7666. And then I can change this into the, what did I do? What did I just do? Okay, fine. Answer to the power of 0.5 per power. you will get the, okay, I can't show you here because I don't have a camera, but what I did is sine -1, 1 minus 0.6, which is 3/5, times 0.7, and then do this by 1/2 power, right? And then the next step is, this is what I did in the calculator, okay? 1.6 times answer, right? There's this thing right here that is very convenient. And then I just press enter, or execute over and over again. Then I get a value of around around this value. Like it just converges to this value. Okay, part 2. Given function, find derivative. So we know that the product derivative, how do I write this? dy dx. Okay, let me just write the formula. For u phi, if u and phi are functions of x, then u phi's derivative, if they are a product function, that will be u derivative phi plus u phi derivative. Okay, so dy dx here would equal to x squared derivative ln x plus x squared times ln x's derivative. So that would be 2x ln x plus x squared times ln x derivative is 1 over x. So this would equal to x to ln x plus 1 if I take x out. Okay? Then part 2. You can also just write this. That's fine. fx. Okay. So now it's a quotient rule. Quotient rules is let me write it here. U over phi equals u derivative phi minus u phi derivative over phi squared. I'm not sure if they included this in the formula booklet, but I memorized it anyways. So if you get used to it, you'll memorize it very quickly. F derivative x will equal to u is e to the 2x power here times phi. Phi here is 4x plus 3 squared, right? Minus u times phi squared derivative over 4x plus 3 squared derivative equals 2e to x times. This is kind of annoying to do, but bear with me, okay? Minus this derivative should be, since this is a what do you call this? A function of another function. Wait, let me just find what it's called. I don't want to teach the wrong stuff. Implicit, I think, or composite function. Okay, it's a composite function. So let's look at this part individually. So 4x plus 3 squared can be looked as, let's say gx is 4x plus 3, right? So now we have gx squared derivative. So this would be 2gx times gx's derivative. This looks hard, right? This looks like yap, okay? But so what we do here is we take the derivative of this thing first, okay? The 2 power. So we will have 2 times 4x plus 3, okay? And then we have the derivative, take the derivative of this inner thing again, and then we multiply it. So it'll be 4, okay? So the total product would be 8 times 4x plus 3. Okay. Then this is the same, so it will be 8 times 4x plus 3, as we just discovered above. And then we can do some cancelling. Boom, boom, boom this, and then boom this. I actually don't want to teach some elementary stuff because y'all are students and y'all should know. Oh, wait. This should be a square, not... I'm stupid. Again, what I was saying was, these are elementary stuff. I hope y'all know these already, like before doing papers. I'm just trying to go through the problem step by step, so like steps like here, at least you should know these. We can cancel some things out, so this would be a 1 power, this would be a 3 power, and then we can take the e to the 2x out, and I think we can take the 2e too. The final answer should be like this, right? So we should take 2 out, we should take e to the 2x out, and we already have what we want at the bottom. So if we take this out, we will get 4x plus 3. This would be minus 4. 4x plus 3 cubed, which is equals to 2e2x 4x minus 1 4x plus 3 cubed. Okay. How did this become a negative 4, you may ask? It's because if I take 2e to the 2x out and we take 2 out here, then we will have a 4 remaining, right? Okay, I think I did an okay job explaining this. Let's do this. Integral of this. How do I explain this? I'm not sure how to explain this. That's a bad part. Let me just copy this down first then. We can do a u substitution. If we let u equals 3x plus 5. Also, this is a very standard question for u substitution. You should like notice it immediately, because you see we are integrating over x, but we have 3x and a composite function in the integrand. And this is just filler. You can just put this out, whatever. If we have u equals 3x plus 5, then du would equals to 3, right? Then 3dx, which means dx equals 1 over 3 du, okay? If you want a separate explanation, I can do a video on it. Then this will turn into integrate. Let's put the 2 out here, as I said. u7 power times 1/3 du. Now, why did we do this u substitution? Because look at how easy this is. This is just 3 over 2 u7 du. So this just turns into 1 over 8 u 8th power plus c. And then we can substitute u back into 3x plus 5 8th power plus c. That was not that bad. Now part 2. I'm just gonna do right here because I don't want to scroll up and down. What if x in this form? So we have we can do long division, I think. I think that's the standard way of doing it, because we want x minus 1, right? So we should actually divide by this, I think. Let me think. Nah, let's do x plus 2. Then this will be a 4 over here. This would be 4 and 8 minus this, -7. Then that means this is a -7, right? So -7, -7, and then -14. This would be 7. And then we have to do 7, 14 again. 0, okay? This is the step for long division. So the top will become x plus 2 times 4x squared minus 7x plus 7. I skipped the coefficients, like it should be like this, right? But I think it's still understandable. And long division means you have to do subtraction for all these intermediate steps. I think you have learned all these before. Not gonna go over them. So the top becomes this, right? So just cancel this out. Now we have to find x minus 1 here and then do a substitution. So I guess we can I should have just done long division with the product, but let's do another long division. Screw it. Now this would be 4, and then -4 minus 3. So this would be 3. So that would be 3 minus 3. And then this subtraction, so this would be a 10, okay? Basically what I did was I eliminated x plus 2. Now we have x minus 1 left. But there is a remainder here, okay? That means we can turn this into 4x plus 3, x minus 1, plus 10. Oh wait, I think I calculated it wrong somehow. This is a negative. Oh, I'm so bad. So this would be a plus. 7 minus 3 is 4. Okay, this would be a 4, and this is a minus. Okay, so it becomes this thing. Oh, it's getting really ugly. I'm so sorry. Let's see how I can write this better. Okay, so basically, let me explain this again. I turned this, I did a long division with x plus 2, and then I found out it's equivalent to this. Then I do another long division with x minus 1. Then I found out it can be turned into this. Now, final step is, well, the second final step actually, we take these two separately, and then you can see cancel. So we have 4x minus 3 plus 4 over x minus 1 left. Boom. Now we integrate this for part B. Integrate fx. So we will have this, right? Because we found out that fx is just equivalent to this. That means we just have to integrate them separately. Minus 3 dx plus integrate x minus 1 for dx. This would be 2x squared 9 3. This would be 3x9 3. This would be, we can take 4 out, and then this is simply just 4 ln x minus 193. 81. Bro, I'm not calculating this shit. Okay. I'm not calculating this, but you have to. Very simple. For all of these, you just take, for example, this one, you just plug in your calculator, 2 times 9 squared minus 2 times 3 squared. Simple. And then for this one, it will be minus 3 times 9, and then plus 3 times 3. Because there's a minus sign here, okay? And then you just sum them all up in your calculator, you'll get this. 4 ln 2. And then does it require, writing in the simplest form. So now you may think this is the simplest form, but no, because ln 8 can be written as, let me think, ln 2 cubed, which is meaning it can be written as this, right? 2 cubed, because we can throw the power out to the front for all logarithmic functions. So this will turn into 12 ln 2 minus 4 ln 2, which is 8 ln 2. Boom. Modeling. My mouth is kind of dry. I'm in recording mid paper. Okay, this is easy enough, I think. We can just take your calc, minus 0.25 log of 3. So this will be log 10h equals 2.4 minus 0.25 log 10 3. We just put 3 into m, and then we will have around 2.2807. Then we know h will equal to, we take 10 power on both sides, will equal to 10 to the 2.2807. So 10 to the answer power will equal to 190.86. Let's just call it 191 because it's 136 fixed. Show that the equation of the model can be written as this. Okay. So just now what I mentioned in the part previously, you can take the power and then dump it in front and become a coefficient, right? But let's take the inverse of this over here. But first, let's move this over here. We'll have, wait, do we move it over here? Let's not do that first. I'm not sure. Equals 2.4 minus log 10 m 0.25 power. Then oh yeah, we do move that over here because log 10h plus log 10m 0.25 equals 2.4, right? And we know that the summation of any two logarithmic functions with the same base, basically what I'm saying is you can sum these together, and the inner part has to be multiplied together. That's just what I was trying to say. So we have this. Then we take the 10th power on both sides, so we have h times this. Basically, we're canceling out the log here. 2.4. 10 to the 2.4 power is 251.2. So we have around h equals 251 over 0.25. With reference to the model, interpret this value of P. So we have P equals to 251, right? I guess we can say if m equals 1, the heart rate is 251, I guess. So what I would write is a mammal of 1 kg has resting heart rate 251. That's what I would write. Beats per minute, of course. Quite a high heart rate, if you ask me. A function f is defined by this. Find f of x. Give your answer as a single fraction. Okay, this question looks kind of easy. What you do is you put fx as x here, because f of x is basically means you take fx as the, what is it called, variable, then 2fx plus 16, fx minus 4, and then we know fx is 2x plus 16, x minus 4. Well, it looks hard, but actually, okay, it is quite hard actually. So what I like to do is I like to multiply both up and down by x minus 4, right? Because this way we can cancel out the most annoying part, the most ugly part. Then we will have 2 times 2x plus 16, parentheses, of course, plus 16 times x minus 4. Because we remember every member has to have a x minus 4 if they are separated by plus or minus. And then I think we just expand this. We have 20x here. 2 times 16 is 32. 32 minus 4 is 64 is minus 32. Minus 2x plus 32. I think we can divide by 2 here, so we can just get... So the final answer should be this, which if I got in my exam I would feel very unsafe, but sure. Oh, let's actually find the inverse function of f here, okay? So we know, let's call y as f, okay? Y equals 2x plus 16, x plus 4, x minus 4. This is the way that I find f inverse. Wait, do I have to find f inverse actually? Because I have the value here. I think we don't. I think because you know fx equals 2x plus 16 over x minus 4. That means we just have to put 12 on the right hand side, right? Because we're finding what makes 12 by f, if that makes sense. Then we solve this. Yeah, I think that's the easier way to do it. Yeah, I don't think I want to explain more on that. Let's continue. Find the exact values of a such that FGA equals GA. So GA here is ln x. And that means FGA equals 2 ln x plus 16 over ln x minus 4. And then equals GA, right? Equals GA means equals ln x. How do we do this? There's a square here. Okay, I think we just assume, let's take a substitution. U equals ln x. Then we will have plus 16 equals, oh yeah, I forgot to use substitution. 2u plus 16 equals u squared minus 4u. Then this will be equals to 6u minus 16 equals 0. Now I feel wrong because this looks so ugly. U minus 8, u plus 2 equals 0. So ln x equals 8 or ln x equals negative 2. But since logarithmic functions cannot, it has x larger than 0, right? Wait. Okay, that doesn't mean anything. Logarithmic functions have their values exceeding 0. Wait, no. X, the domain, not the range. X must be larger than 0. Okay, ignore what I said just now. That is useless. That is useless. We take the e to the power of on both sides. I misread it. I misread it. My bad. So we have x equals e8 or x equals e to negative 2. Okay, I should actually write a for x. Whatever. I did a poor job explaining this. Okay, trigonometry. And in my opinion, trigonometry is definitely the harder questions in pure free, because there are a lot of solutions inside one question and you might miss it. But let's just hope that there are less points associated with these trigonometry questions. We have to show that this can be transformed into this. Now, first of all, we can turn cosine theta minus 60 into just cosine theta times cosine 60 minus, or was it plus? I think it's plus sine theta times sine 60. We can turn this into theta only variable, not theta minus 60, if that makes sense. Then we can compute these, which is cosine theta. Cosine sine 60 degrees is square root of 3 over 2, so that would be square root of 3 sine theta, because the over 2 and the 2 in front cancels out. Then that means we can just move this over to the right, so we have cosine theta equals 3 minus root 3 sine theta. That means 3 minus square root of 3, 1 over equals sine theta over cosine theta equals tangent theta. And what I did was I moved this part to the left, and then I moved cosine theta to the right, if that makes sense. And this part right here, how do we turn it into this beautiful stuff? I can just multiply it by the conjugate, which is 3 plus square root of 3. That cancels out the ugly stuff in the bottom. Then we will have 9 minus square root of 3 squared, 3 plus square root of 3, that is 6, 3 plus square root of 3. So we just proved that tangent theta equals this from our original statement. And then it says, hence solve this equation. This is I think I'm supposed to do something with I'm supposed to do something with theta minus 60, right? So I'm trying to find theta minus 60 here. Okay. So this is how I would do it. So you see 2 cosine, 3 sine here, right? And then you can see that minus 70 and minus 10. So that means there is a 60-degree difference, which is what we exactly want. So what we do is u equals 2x minus 10. Then that means 2 cosine 2x minus 10 is u, right? And then this will be minus 60 degrees equals 3 sine u. Then that means the solution, this thing will turn entirely into tangent u equals 1/6 3 plus square root of 3, because we just proved that, right? Then how do we find the solution for this? We take the arctangent of it. So we have u equals arctan of this thing right here. Where's my calculator? Oh, here. Oh wait, u is 2x plus minus 10. Should I actually turn it back into? Okay, no. We can't do that first. We have to do it step by step. So this will be 3 plus root 3 over. Wait, how do I use this calculator? Subscribe so I can buy a new calculator, because this calculator is garbage. And of course it's degrees, so I have to do this. I get u equals 2x minus 10 equals around 38.26 degrees. Okay, let's just write two decimals first, because we will need it. Then that means 2x equals 48.26 degrees. So that means x equals 24.1 degrees. And we have to consider the second case, which is, let me move it here a bit first. So this thing right here, right, it can also equal to 38.26 degrees plus 90 degrees. You may ask, 180 degrees I meant. You may ask, why? Because tangent has a period of 180 degrees, right? So that means every time we have a solution, the next solution will be plus 180 degrees. Or we can find the previous answer, which is minus 180 degrees. We also have to consider this case. But after you calculate this, you will find out it's like negative 140 degrees or something. And then that means this is out of range for this one right here, right? So obviously, we have to not consider that case. So the only two solutions will be this and this. Now let's compute this would be 218.26. 2x equals 228.26 because we have to add 10 degrees, and then x will be equal to 114.1 degrees. Okay. Yeah, there are only two solutions here. I think the tricky part is to how you find the other solution, and honestly I have a hard time explaining this to all my students too, because sine and cosine are different from tangent, and yet they also have different solutions. But my advice is to go to Desmos graphing, Desmos graphing calculator, and then find just plug in the graph of the function, and then you will see the solutions, all the solutions laying. And you can also find that the period and the shape of the graph work differently. It's hard to explain. Let's just go to the next question. Now we have to find the coordinates of point P, and obviously point P is the lowest point, right? So where's the lowest point of a absolute value function? Is when this equals 0, right? Because its lowest value is 0. So if this equals 0, then x would equal 11 over 3, and then y or f11 over 3 would equal to, this thing is 0, right? So it will only equal negative 4. So the point P will have this coordinates. Solve fx equals 8. Now obviously there will be two solutions, either this or equals to this, equals 8, then we will have, I shouldn't write that, 15, 28 plus 15, so that would be 23 over 3. And then this will be 11 minus 4, 7, 8 minus 7, 1 over 3 should be. The line L has equation y equals mx, where m is a constant, Given that L intersects the graph at exactly 1 point, find the possible values of m. So immediately, you can imagine the line must pass through, because it's a y equals mx, right? It doesn't have a plus c, so that means it is a line. God damn it! It is a line like around this, right? And it can be here, it can be here, it can be like this. But how do we have a line that passes through this function at only 1 point, right? Is it only 1 point? Yeah, exactly 1 point. So look, if we extend this line, it would definitely pass through here, right? It will definitely have another intersection. So there will be two individual intersections. That is not what we want. We only want one. So how do we do this? One of the cases is if this is parallel, right? If this is parallel, that means it never touches P. It never touches the absolute function. So that means either m equals 3 is one of the solutions, because look, 3 is already given here. That means if we have the gradient the same as this absolute function, that means it is literally paralleled like this. Okay, that's not really parallel, but you get the point. You get the point. We have to have the same slope. And actually, since it only passes through here, it only passes through at this point, right? So that means any gradient larger than 3 also works. I just realized. Yeah, look at this. This is beautiful. Okay, so it should be larger than or equal to 3. I got that kind of wrong. And the next case is if this is a negative slope, right? So you will see at this point it only touches P, right? But if anything above, it would be too much. And then the other cases, look, this doesn't touch the line at all, but if we have a slope deep enough, we will also intersect this part of P. All right. So we will have to have it not parallel to it, let's just say. Oh, this is so hard to explain, bro. So we have to solve, I think, mx equals, or actually, okay. Just now I mentioned one of the cases is it touches at P exactly, right? So let's plug that. That means the line must have P on it, right? So that means -4 equals m times 11 over 3. So that means m equals -12 over 11. This is the second case. This is the second solution. Okay. And then now let's do the third one. The third one is, as I said, if it is like, if it does this, right? If it has a deeper slope than -3, because this slope is -3, this slope is +3. So as long as it has a deeper slope than -3, it intersects at least one point. Okay, surely I explained that well enough. The graph with equation y equals fx is transformed onto the graph with equation whatever this is, given that the vertex of the graph with equation y equals af x minus b is... I don't understand this. Wait a minute. Okay. So basically, this point right here is transformed into here, which is 5/16. That is very bad scale, but let's assume that is 5/16. So that means That means a times fx minus b would equal to a times 3x minus b minus 11 minus 4, like this, okay? Then it also mentioned 5 is the vertex, so that means 3x minus 3b minus 11, it should be 5 here, equals 0, exactly 0. So that means b must equal to 4 over 3, if that makes sense. So that means we will have a times 3x 3 over 4 minus 3 over 4, that means minus 15 minus 4. So as you can see, at this point right here, wait a minute, this shouldn't be minus 4, right? Oh, there should be a yeah, there should be a parenthesis here. Okay, as you can see, at point if x equals 5, then this thing equals 0, right? So that makes sense. That was the idea of the vertex. And then we know that at point 5, y equals this equals 16. So that means a must equal to negative 4, because a times negative 4 equals 16, right? So a must be negative 4. And then b equals 4 over 3. Let me just write that down because it's finding a and b. Okay, that is tough for a 2-point question. How much more do I have? I have 2 more questions left. For this, we can do something like, we can do dx dy would equal to, this is very ugly. Let me think. So first of all, we know that e to the 2x derivative will equal to 2e2x, right? So we do this as the first step. That would be 2e2 tangent y. Then we have to find the derivative of tangent y. So that would be tan y derivative. Then that would equal to, actually it should be 2 tan y. It should be 2 tan y. Yeah. That would be 2 times. Wait, no. Okay, my bad. It should be 1 tan y. That would be equal to 2e2 tan y times secant squared y, because the derivative of tangent y is secant squared y. And then what does he want? He wants dy dx. They want dy dx. So all this for 4 points. There's, come on, man. It's equal to, let me think here. Okay, so I can substitute this as x. Then for secant y, we know that secant is equal to 1 plus tangent. I think this can do something here, because we know tangent y is, we know that ln x equals ln e2 tan y, right? Which is equals to 2 tan y. So that means tangent y equals ln x over 2. So that means this would actually equal to 2x 1 plus ln x over 2 squares parentheses. Then that means dy dx will equals to this thing, this entire thing flipped. Okay. 1. Am I missing something? I feel like I am. No. I think not. Let's take this 4 out. Let's take this 2 squared out. That would be 2x plus ln x squared over 2, and then 1 on top. That means we can multiply both up and down by 2. That would give us 4x plus ln squared x, and then on top it would be 2. And then there should be an x here, there should be an x here, and then we can take x out again because this stupid question wants us to do this way. I think this is kind of a tough question, but all you have to do is find the derivative of this first, composite function derivative, and then we can substitute this back into x, and then we can do a trigonometry identity for this, not substitution. Then we can find out that tangent y is actually ln x over 2 by this, and then we can transform this into this. We were actually finding dx over dy, right? So how do you find dy over dx? We can just flip this over, because we are actually flipping these two things, right? And then these are just algebra. These are filler algebra, not that hard. Wait, I have 2 more questions? Oh, god damn it. Okay, do not do this in January. Do not ever do any paper in January, unless you are so confident. My experience with January papers are terrible, honestly. Transform this into this. Okay. So x plus 8 plus. Let's just expand this. And then we know that 2 sine x cosine x actually equals to sine squared x, right? So that means we can turn this into 8 plus sine 2x, not sine squared x. I'm so stupid. Wait, the 3 is actually in here, so actually 6. What else? What else can we do? I guess because we need to find 2x here, so we have to find cosine 2x from here, I guess. So we know that cosine 2x equals cosine squared x minus sine squared x, which equals to 1 minus 2 sine squared x. So that means 2 sine squared x actually equals to 1 minus cosine 2x. So that means this thing can be turned into 3 cosine 2x plus 3. Yeah, I did that the wrong way. Plus and then minus. Then we have to find r here because god damn it, this is so annoying. R equals squared plus 3 squared equals to (904 plus 9 equals). I'm missing a parenthesis. Can this calculator actually do something? Oh my god. And of course, you give me a numeric answer, which is not what I want. I'll just do it by my hand. Okay. I'll just solve a square root by hand. 45 over 4. That means this would be 3 root 2. Okay, so r equals this, right? Then that means 8 plus 3 root 5 over 2 of sine 2x plus, I haven't found this number yet. There is a degree here, and we have to find it in radians. How do you find it? Well, let's just take tangent alpha actually equals to 3 over 3 over 2. So you would get alpha equals around 1.107. Remember to use radians, by the way. 1.107. Then this is 8 minus 3, so that would be 5. And there we have it. There you go. That's the part A done. Next. Figure 2 is a sketch of the curve of equations. State the range. The range means the maximum value and the lowest value, right? So we know that would only depend on these two numbers, because this is from -1 to 1, so that means the range is actually very simply this, and then this. Part C. This is the minimum point, and we have to find the coordinates. And so we will have to find 5 plus 3 sine 2x plus 1.107 equals 5 minus this. 5 and 5 cancels out. This turns into -1. So we are finding 2x plus 1.107 equals either 3 over 2 pi? Is it 3 over 2 pi? No. This is ours.
This is 7 over 2 pi, right? Then after solving, you should get x equal 4.94 if we take 3 significant figures. Oh yeah, you might ask, how did I pull 7 over 2 pi out of my ass just now? The answer is, we know that in a science, I don't know if you guys use the circle or the graph way. Let's just use the graph way, okay? We have to find -1 here, right? This is 3 over 2 pi, x equals. But we know that would correspond to this point, right? So we have to add another 2 pi to get m. So we add 2 pi, we get 7 over 2 pi. Oh, finally. Okay. Start by finding the rate of growth. So rate of growth just basically means the derivative dt would equal to 180e.2t, because we have to this is equal to times this and then times 0.2, okay? Because derivative of 0.02 0.2t is 0.2. What are we doing here? There are 10,000 insects in population B at the start of a study. So that means when t equals 0, this equals 8,000. So that means p is 2,000. So p is 2,000. Why, you may ask? Because at the start of the study, it means t equals 0. That means ekt equals 1, because e to the 0 power is 1. That means p is 2,000, because 8,000 plus p equals 10,000, so p is 2,000, so this is 2,000. And then there are 11,507. So nb equals 8k plus 2k e k times 4 equals 11570. I'm just gonna stop yapping and do this. There you go. There is the answer. So we have nb equals, I just have to write 0.145. And this is 2,000. And then calculate the value of t, big T. What is a big T? They have the same pop after t years. So na equals nb. So 8,000 plus 900 e.02 t equals 8,000 plus 2,000 e to the 0.0145 t. Cancel. And then that means 9 over 20 e 0.55 t equals 1. So that means e.55t equals 20/9. Then we take the log of it again. 0.55t equals 20/9 ln. Then we divide both sides by 2.55. That is the final answer. The final answer is ln 20/9 over 0.55, which is. Wait, did I get something wrong again? This is a 0.055. This is a 0.055, by the way. So we get t equals 14.5, around that value. Okay. This step, how did I get this step? Is you just move this thing over here. So divide both sides by 2000 times e to the 0.0445t. Then you get this, and then the right hand side is 1. That's basically what I did. Okay, I'm done here. My mouth is so dry.